Okay, we are recording. First one I'll do is page 305, number 12. And it's prove the identity that cotangent of alpha over 2 is equal to sine of alpha over 1 minus cosine of alpha. All right. Well, I think I would start on the right-hand side, and I would multiply top and bottom by the conjugate of the bottom. Right. So then that will give me a sine of alpha. I'm not going to distribute that yet, just because who knows what's going to happen. On the bottom, it's a 1 minus cosine squared, which we know is sine squared. That's over sine squared. And then that means that this sign up top will cancel with one of the signs in the bottom. And so that's 1 plus cosine of alpha over sine, which is the reciprocal of tangent of the half angle. And then that means that it's cotangent. Check. That would be, yeah, you'd have to use one of the identities for that one. All right, page 305, number 1. They want you to use the sum or difference. So you got to make sure you read the directions, because this one says using the sum or difference to find the tangent of 5 pi over 12. Versus I could also ask you to use the half angle identity to find this one, but it says to use the sum or difference one. So what adds up to 5 pi over 12? Well, 2 pi over 12 plus 3 pi over 12 will do it. And those guys simplify to pi over 6 and pi over 4. And then the identity for this is the top looks like a fake distribute, pi over 6 plus tangent of pi over 4, and then divided by 1 minus, and then multiply them. All right, so pi over 6 is a 30 degree, and a 30 degree is a short one. And so tangent would be rad 3 over 3. And then tangent of pi over 4 is 1. That's the 45 degree. And then we'll have 1 minus rad 3 over 3, and then times 1. And so then that gives you a rad 3 over 3 plus 1 over 1 minus rad 3 over 3. And you got to rationalize this. So I'm going to multiply top and bottom by 1 plus rad 3 over 3. To get rid of the radical that's in the bottom there. And so then that will give you, let me see if I come all the way over here, if I will. Hopefully it'll leave me enough room. Okay, so then that gives me, what, a rad 3 over 3 First times first, it'll be plus a 3 over 9, so a 1/3, plus a 1, and then plus another red 3 over 3. And then the bottom is the difference of two squares, so it'll be 1 squared minus red 3 over 3 squared, which is 1/3. And so that will give you a, 2 red 3 over 3 plus 4/3 all over 3 over 3 minus 1 over 3 is a 2 over 3, which will end up simplifying to, they both have a denominator of 3, so a 2 red 3 plus 4 over 2. 2 goes into all of that, and so a rad 3 plus 2 is your answer, since the 2 goes into all of those guys. Okay. Page 325, number 19. All right, I don't know how I'm going to show you this on the calculator, but I will try. Is that which one it was? Page 325, number 19. We've got a cosine squared of x greater than x minus 1. So what you want to do is get everything over to one side. So I'm going to subtract the x and add the 1, and then I've got greater than 0. You're going to put this guy into your graphing calculator as y1. Saying greater than 0 means I want the part that is above the x-axis. Make sure your calculator is in radian mode. And we'll do y equals cosine squared minus x and then plus 1 under y1. I'm going to hit zoom trig. I'll draw a little sketch of what my graph looks like. They want it from x is greater than or equal to 0 and strictly less than 2 pi. And so it looks like something like that. And so I want when it's above the x-axis, so the part I want, I'm going to give all of the x values that correspond to this part here. Yeah. And so it'll be all these x values right there. So I know it'll start at 0, and then I just need to figure out what is that 0 right there. And to find that, you're going to do second trace to bring up the calculate menu, and then number 2, just push the button 2 for zeros, and then it'll say left bound question mark. You just want to be left of this 0. You want to put, your little cursor somewhere around here and hit enter, and then under right bound question mark. So it'll say left bound question mark. You want to make sure your cursor is to the left, right? And then hit enter. And then on right bound question mark, you're going to use your little right arrow. Use that little right arrow to move your cursor somewhere over here, somewhere below the x-axis. And so I move it over and then hit enter. And then it'll say guess. For that, you can just hit enter. You don't need to move your cursor at all. And so I get that it says 0, and then it says x equals 1.1596953, and then it says y equals 0. So then that means that's your x value there. And so it's all of the values from x until 1.16. And in interval notation, that would be a 0 to 1.16, like that. So did it say, this, your book didn't say how they wanted it, so either one is fine. If they say interval notation, then you got to answer it this way. What do we tell you to do? It doesn't say, so. That's good enough. All right. I know doing the Griffin calculator ones are hard for me to show you on there, but it's the best I can do. Okay, so that was page 325, number 19. Do 13 from the quiz. All right, so quiz 13. I'm going to show you two different ways. You can choose whichever way you want. Inequality, right? So there's going to be lots of different values. When you're talking about cosine, you're talking about, you know, if here's your theta, and this is your x, and this is your y, and this is your r, your cosine is x over r, right? And if you're on the unit circle, your radius is 1. And so when you're talking about cosine, you're talking about this part right here, this adjacent side of each of the triangles, right? And so one way to do this is by looking at the unit circle and the triangles, all the right triangles, and their sides. All right, so cosine of x is equal to 1/2 as a 60-degree angle. So here at pi over 3. But also, oops, pretend like that's a straight line. That did not work. Okay. Straight line. That's a little bit better. It also happens here. Your cosine is 1/2. Cosine is that side of your triangle right there. And that value is at 5 pi over 3. Now in the notes we had absolute values over that sign, and so we also considered the second and third quadrant, because once you take the absolute value of it, then we considered that. But this is all positive, and so you're only worried about these two. Only in quadrant 1 and 4 is when your cosine is positive. Now, so what they're asking you is, when are the sides of your triangles larger than 1/2? When are they longer than this little section right there? Well, if you drew a triangle closer to this, the y-axis, right? Well, your cosine side, that adjacent side of the triangle, is shorter. It's less than 1/2, so you don't want to go that way. Instead, you want all of the values that are bigger, right? So I want, like, this triangle would definitely give me a longer cosine, a greater cosine, or a greater adjacent side. So would this one. So would this one. See how the adjacent side is all longer? And that one too, all of those, right? So if we're going around the circle, it's all of these guys and all of the ones in between, right? They're all going to give me an adjacent side longer than this 1/2 side right there. The same thing happens down in the fourth quadrant, right? If I'm down here, like, that one's going to be longer, and so is that one, and so is that one, and so is that one, all of those guys. So it's all of these ones and all of these ones that create a cosine that's larger than 1/2. Now, you've got to give your answer, though, Where did it say it? It said that x was greater than or equal to 0 and less than 2 pi. So that means you got to go around. Here's 0 and also 2 pi, right? So you got to go around this way. And so cosine of x will be greater than 1/2 from 0 until you reach pi over 3. I'm putting or equal to because this or equal to, so you do include it. But then as you're going around the circle, nope, 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 doesn't count. All of those are less than. But then you go bigger again from 5 pi over 3 to 2 pi. I'm not including 2 pi because they restricted and didn't include it there. So that's how you write it in inequalities. If they write it in, want you to write it in interval notation, that's 0 to pi over 3 unioned with 5 pi over 3 to 2 pi. Okay, so that's figuring it out using the unit circle and the sides of the triangles. Another way you can do it too, which I personally like better, but most students like this way better, but I like where if you graph cosine, right, and cosine goes from 1 down to -1, and you start here and then you go to 0 and then down to -1 and back up to 0 and then up to 1. So cosine looks like this. And it's not letting me draw. Come on. There we go. Okay, so there's cosine. And then you want, when is this greater than 1/2? So here's 1/2. Y equals 1/2, maybe. Yeah. So what I want is, when is cosine of x, which is the curvy guy, greater than y equals 1/2? Well, it's greater from here to here. Right? It's above the line there, and it's also above the line from here to here. Right? And so what are those x values? Well, I know that's 2 pi. This guy right here is 5 pi over 3. It's when cosine is equal to 1/2. This guy is pi over 3, and this guy was 0. And so you're giving all of the x values from here to here, and then from here to here, which ends up giving you the same exact answer of from 0 to pi over 3, and then again from 5 pi over 3 to 2 pi. So again, we had absolute value in the notes. This one did not have absolute value. And two different ways of doing it. You choose which way you like better. How would the answer change if it was sine, since you always look at the height for sine? It would be much different, right? You're looking at the y values. So sine looks like this. And if you want just when sine is bigger than 1/2, it'll only be from here to here, right? This is if sine of x was greater than or equal to 1/2. Well, sine is 1/2 at pi over 6, and then again at 5 pi over 6. And so it would just be from pi over 6 to 5 pi over 6. And if you looked at it from looking at the unit circle, it's 1/2 here, and then again here. And it's all of these values that will have triangles with a height larger. See, all of your heights are taller than sine. You're looking at the heights of the triangle, so you're looking at these guys. And so that's why it's from pi over 6 to 5 pi over 6. So a huge difference, sine versus cosine. Sine, you're looking at the heights of the triangles. Cosine, you're looking at the adjacent sides of the triangles. Okay, so that was 13 from the quiz. We are now on page 322, number 17. All right. Well, crap. That's basically the one I just did. Huh? Okay, page 322, number 17. You don't need graphing calculator because this will give you, and it's for x is from 0 to 2 pi. Okay, so this is sine squared of x is greater than or equal to a negative 1/2. So when is it? Well, okay, I don't even need to do any more. When is something squared greater than or equal to a negative? Always positive. And that's a negative, right? And so all real numbers. Something squared is always positive. So if you're doing an inequality of something squared, when is it greater than or equal to a negative? Always. Always and forever. So that was 322, number 17. Number 11 from the quiz. All right, I've got sine of 3x is equal to rad 3 over 2. The 3x tells you you must go around the circle 3 times to pick up answers. You got to go around 3 times. So, first of all, let's figure out when is an angle, what angles have sine equal to rad 3 over 2. So here at pi over 3, and then also at 2 pi over 3. We're not doing a range because this is just equal to, right? So your angle, which this angle is 3x, sine of your angle will equal rad 3 over 2 at pi over 3, and then again at 2 pi over 3. That's just with the first revolution around the circle. Now, on the second revolution, you're going to be going all the way around, so 2 pi, and then plus another pi over 3. So what you're going to do is you're going to add 2 pi to both of these angles to get the second revolution, the angles when you go around the second time. Adding 2 pi is the same as adding 6 pi over 3, so that's a 7 pi over 3 and an 8 pi over 3. And then we're going to add another 2 pi to get the third revolution angles. So that would be 13 pi over 3, and adding 6 would be 14 pi over 3. So those are the third time around. All right, then you've got one more step, and that is, right now you have solved for 3x. You need to solve for x by dividing both sides of the equation by 3. And that will just give you a pi over 9 and a 2 pi over 9 and a 7 pi over 9 and an 8 pi over 9 and a 13 pi over 9 and a 14 pi over 9. There you go. That was 11 on the quiz. All right, we are on page 305, number 11. So we want to prove this identity that cosine of 2 alpha is equal to cotangent of alpha minus tangent of alpha all over cotangent of alpha plus tangent of alpha. So I would definitely work on the right-hand side. And I think what I would do first is write it as cotangent is 1 over tangent. And that's like tangent over 1. And then divided by 1 over tangent plus tangent over 1. And then we would need a common denominator in order to subtract these. So multiply this guy by tan over tan. And same thing here, tangent over tangent. So that you get a 1 minus tangent squared over tangent, and then all over a 1 plus tangent squared, and then over tangent. So just adding the fractions. Your denominators will cancel because they are identical. The other thing is I have a 1 minus tangent squared, but 1 plus tangent squared is secant squared because I tan in a second. And then if you split these up, you'll end up with a 1 over secant squared, which is cosine squared, and then a minus tangent squared over secant squared. Tangent over secant is sine over cosine over 1 over cosine, and so it ends up being a sine, right? And then, but we have squared on them, so it's a sine squared. And cosine squared minus sine squared is an identity for cosine of 2 alpha. There you go. 324, number 3. Okay. They give you that sine of alpha is negative 7 over 25. They give you tangent of beta is positive 3 over 4. They tell you alpha is between pi and 3 pi over 2, and that beta is between 0 and pi over 2. And they want you to find, so they want us to find cosine of alpha minus beta, right? Well, so that's a difference one. And so it's a cosine, cosine, sine, sine. Change the sign in the middle. Plus. So I need to find cosine, I need cosine and sine of each of these guys. So when they tell you alpha is between pi and 3 pi over 2, that means alpha is here in quadrant 3. With the sine is y over r. Your r is always positive, so that makes that a 25, a negative 7, and then what's x? Is it a Pythag triple? Yes, it is. 7, 24, 25. But you can do Pythagorean theorem if you're not sure. It's a negative because you're in quadrant 3. Yeah. So that means you've got sine of alpha is that means cosine of alpha is negative 24 over 25. Okay, so this is for alpha. Okay, so cosine of alpha is negative 24 over 25. I know that it's negative because it's in quadrant 3. And then sine of alpha they gave me was negative 7 over 25. All right, then for beta, beta's in quadrant 1 because they tell us it's between 0 and pi over 2. And opposite over adjacent. Opposite over adjacent. And that makes your radius of 5. Use Pythag if you don't know it. And then, so cosine of beta would be, cosine of beta is adjacent over hypotenuse, and sine of beta is opposite over hypotenuse. So we've got a 4 over 5 here and a 3 over 5 here. And then multiplying those together, you'll get a negative 96 over 125 and plus a negative 21 over 125. And adding those will give you a negative 117 over 125. All right. Okay, so I see you wrote 324 number 3, but then, oh, then you said never mind, but I did it anyway. Okay, well, hopefully that helps somebody. About 314, 11. Page 315, number 11 says, solve 9 sine of x minus 1 equals sine of x plus 2. Okay, so this one's a pretty straightforward one, and that combine like terms. So subtracting sine of x will give you an 8 sine of x, and then adding 1 over will give you a 3. Dividing both sides by 8 gives you sine of x is equal to 3 over 8. So you need your calculator for this one, right? You also need to keep in mind that your sign is positive in quadrant 1 and also in quadrant 2. Your calculator is only going to give you a quadrant 1 answer when you do inverse sine of 3 over 8, which they tell you x is between 0 and 2 pi. So you need to make sure you're in radian mode. Yeah. And we do inverse sine of 3 divided by 8. And I get x is approximately 0.384. Yeah. So that's this angle here to give you the quadrant 1 angle. But I also need this one, right? Well, here's what I know. I know that this is also 0.384. If this is 0.38, then so is that one. And this is pi, so the other angle is pi minus 0.38. Pi minus my answer, and that gives me 2.757. So 2.76 and 3.384. Two answers. I don't know why I kept 2 decimals here. Let me cross out the there. I don't know why I kept 3 decimals in one of them and 2 in the other. But all right, that was 315 number 11, 315 number 24. Okay. Whoops. Page 3. Page 315, number 24, is cosine of x is less than negative rad 3 over 2. All right. This is when I really want to do this. this, right? And here's -1 and negative red 3 over 2. Let's say it's about there. Well, it's actually lower than that. Let's undo that. Negative red 3 over 2 is about 0.86. So it's like here. And when is cosine less than it, I want this section right here. From here to here. So whatever x value that is to whatever x value that is. And we want all of these guys in between. And so when is x equal to negative red 3 over 2? Cosine is red 3 over 2 on the 30-degree reference angles, but negative in quadrant 3, so 7 pi over 6, and then again at 11 pi over, wait, no, taking it back, not true. Cosine is negative in quadrant 2 and 3. So cosine is a negative red 3 over 2 here and here, which is 5 pi over 6 and 7 pi over 6. And so you want just that little section there in between. Strictly less than because of the inequality there. If you're looking at the sides of the triangle, you want less than a negative, right? So here's negative red 3 over 2. So when is it less than? From here to here is when you'll have x values that are smaller than, they'll be between negative red 3 over 2 and -1. Hopefully that helped. 316, number 52. All right, so now we've got absolute value of sine of x is less than or equal to red 3 over 2. Okay. So here, if you're doing the unit circle, it's absolute value this time. So we do care about positives and negatives. Sine is red 3 over 2 and it's the tall triangle. So pi over 3. And its sine is positive red 3 over 2 at 2 pi over 3. It's negative, oh, that was ugly, but at that's 4 pi over 3, and then again here at 5 pi over 3. Okay, so we want, when are your heights, the heights of the triangle, shorter than these guys? You know, and so they're going to be shorter because sine is the heights of the triangle, right? So we want, like, this guy's shorter, and so is that one, and so is that one. And in between here, pi over 3 and 2 pi over 3, the heights of the triangles are actually taller, right? If you drew the triangle, ooh, that's taller. Nope, we don't want that one. And then if you draw the triangles this way, they're shorter, they're shorter, they're shorter, they're still shorter, they're still shorter, they're still shorter, right? So we got all of those guys up until 4 pi over 3. If you keep on going here, right, that triangle has a higher height, so you don't want that. And anyway, same thing. So all of those guys are also going to be shorter. So you're going around the circle. because it said from 0 to 2 pi. So you're starting here at 0 and you're going around. And so until you hit pi over 3, they're all shorter. So from 0 to pi over 3. Unioned with, skipping this section because those are all taller. But from 2 pi over 3 all the way to 4 pi over 3, those are all shorter. 2 pi over 3 to 4 pi over 3. And then as we're going around, you're going to skip all of those because all of these triangles, the heights would be taller. But then from 5 pi over 3 to 2 pi, they're shorter. All right, so there's your answers. If you were to do it using the graphs instead of the unit circle, you would do, so the sine graph looks like this, right? But then absolute value of sine turns that part that is underneath the x-axis to above. So that's y equals the absolute value of sine. And then rad 3 over 2 would be here. And when do you want it? You want when it's less than. So you want this section here, this one, and that one. And those values correspond to, okay, there's pi over 3, there's 2 pi over 3 to 4 pi over 3, and then 5 pi over 3, and then that's 2 pi. So you want those guys, and those guys from 0. So that's how you would figure it out that way. I think that was the exact one we did in the notes, maybe. Looks familiar anyway. Okay, so that was 316, 52, 314, number 21. Oh man, you guys are really struggling with these inequalities, huh? 21 and 23. Oh, Lordy. 21 says cosine of x is less than 0. Well, I don't even need to do any graphs. When is cosine of x negative? From pi over 2 until 3 pi over 2. All of these guys have negative cosines. So that's your answer. That's saying less than 0 means when cosine is negative. So that was that one. 23 is very similar to the one we just did. Is it different? I feel like I just did this one. Maybe not. Okay. If you're doing the unit circle way, sine of x is rad 3 over 2 here and here. So 2 pi over 3 and pi over 3. Sine of x, that's the heights of your triangle. So these guys, right? And when are your heights larger? Well, there and here and here. They're all taller from here to here. And so your answer is from pi over 3 to 2 pi over 3. Interval notation would be pi over 3 comma 2 pi over 3, like that. If you were to graph the picture, and here's rad 3 over 2, you just want this little part right there, right in between there, which ends up being pi over 3 to 2 pi over 3. All right, that was 314, 290. right, so they want you to express in terms of sine, cosine, or tangent of one angle. And it's cosine of 5 pi over 12 times cosine of 7 pi over 8 minus sine of 5 pi over 12 times sine of 7 pi over 8. So you got to notice the pattern that it's cosine, cosine, sine, sine. Change the sign in the middle. Yeah? So that means this is equivalent to cosine of the first guy plus cosine of the second angle. And it's a 5 pi over 12 plus a 7 pi over 8. And then you got to add fractions. You need a common denominator, which would be what? I think it's 24. So times 2 over 2, and this would be times 3 over 3. So that you get a cosine of 10 pi over 24 plus a 21 pi over 24, which gives you a cosine of 31 pi over 24. There you go. Yeah, seeing that pattern is a big thing in math. Page 314, 39. I want you to solve tangent of x equals cotangent of x. So the first thing you want to do is subtract the cotangent. You want to get this guy an equation set equal to 0. And then what I would do is rewrite cotangent in terms of 1 over tangent. And then get a common denominator so you can subtract. So you would multiply both sides of the equation by tangent squared. Right? Multiply both sides, not by tangent squared, but by tangent of x. So just getting a common denominator and solving for that. And you end up with tangent squared of x minus 1 equals 0. Well, that gives you that tangent squared is equal to positive 1, so that tangent of x is equal to plus or minus 1. And so when is tangent equal to plus or minus 1? Well, tangent's equal to positive 1 here in quadrant 1 and then in quadrant 3. And that's 45-degree reference angles, which would be pi over 4 and 5 pi over 4. And then tangent of x is equal to negative 1 here in quadrant 2 and then again in quadrant 4. Well, that's 3 pi over 4 and 7 pi over 4. So if your answer was between 0 and 2 pi, there's your answer. It looks like this section said for all values of x. I told my students I'm fine with taking each of these answers and just going plus 2 pi k. So for all values, it means that you would take each of these answers and go plus 2 pi k. And 3 pi over 4 is the next one, really. Plus 2 pi k. And then 5 pi over 4 plus 2 pi k. And 7 pi over 4 plus 2 pi k, where for all of these guys, k is an integer. Now you can simplify these because it turns out that they are just, what is that, pi over, they're all like 1, 3, 5, 7. They're all the odd powers of pi over 4. So there is a way to simplify it. I'm not going to bother. Let me see. Who asked for this question? 315. Number, which one did I just do? 39? 314 number. 39, Samantha W. I don't know who your teacher is, Samantha W. But hopefully they allow you to just leave it like that. I mean, technically, they're all odd powers, and you do odd powers. by 2n minus 1 or 2n plus 1. They're odd powers of pi over 4, where n is an integer. I think that's how your book writes. Well, they write it a little bit differently than that, but that would be all of them. I'm fine with you just taking each of your answers and just adding 2 pi k to them, because it's just all of the coterminal angles that work with it. But just in case, if your teacher said you got to simplify it, I don't think they do that, but whatever. All right, page 315, number 13. Ooh, okay. They're wanting you to solve for where x is between 0 and 2 pi, and it's a 3 tangent of x times sine of x plus sine of x equals 0. All right, so what you got to do is factor. Factor out the GCF, which will give you 3 tangent of x plus 1. And so that means sine of x equals 0, or 3 tangent of x plus 1 equals 0. And this will give you tangent of x equals negative 1/3. All right, this sine of x equals 0 is when you've memorized, right? Sine of x equals 0 here and here, so your x will be 0 and pi. But this one, got to use your calculator. But here's what I know. I know tangent is negative here and here. Your calculator is going to give you the negative angle here. So you'll do x equals inverse tangent of negative 1/3. You're in radian mode. And that'll give you a negative 0.321, right? But you can't give that answer because they want you between 0 and 2 pi. So you got to go around this way. And so, and then the other thing is that this guy is 0.32. So if I take that and I go pi minus 0.32, that'll give me the quadrant 2 angle, and 2 pi minus 0.32 will give me the quadrant 4 angle. So this one was 2.82, and this one gives me 5.96. So you've got 4 answers, 0 and pi, and 2.82 with and 5.96. So all of their 4 answers together. Okay, so that was 315. Number 13. For number 13 on the quiz, okay, I already answered that question. Will there be a surveillance camera problem on the test? I don't know. There could be. Was that this section? I don't remember. Oh, because it was adding the 2 angles. Did we say that there was a word problem? I don't remember saying there was a word problem. I don't remember saying that there was on that little review thing that there was a word problem using them. So, all right, 302, number 5. What time do we got? Okay. Page 302, number 5. Says to use double or half angle identities. To find tangent of 11 pi over 8. All right, so here's what I know. I know 11 pi over 8 is 11 pi over 4 divided by 2. Do you agree? Since 11 pi over 8 would be 11 pi over 4 times 1/2, right? So this upper part, this guy here is the theta, right, that you're going to plug into your half angle identity, which I don't remember what letters we used. I'm going to use theta right now. All right, so what I know is I've got three formulas for you to use for tangent of the half angle. You use any one you want. Personally, I would use 1 minus cosine of theta over sine of theta. That's my personal preference if I get to choose. You have to have them all memorized for tomorrow, right? But then when you go to use them on what would it be, Thursday, you can use any of them. So this theta over 2 is this theta over 2. That means it's this theta and it's that theta. So it's 11 pi over 4 that gets plugged in there. So this is and notice there's no plus or minus. I don't have to figure out plus or minus or anything like that because it's not in the formula. So I've got 1 minus cosine of 11 pi over 4 over sine of 11 pi over 4. All right, so we got to figure out where the heck is 11 pi over 4. Well, it's more than, so 2 pi would be equivalent to 8 pi over 4, right? And so that means they've gone around the circle and then another 3 pi over 4. So 11 pi over 4 is coterminal with 3 pi over 4, right? 11 pi over 4 minus the 2 pi will give you 3 pi over 4. So they have the same cosine and sine values. So that's all right, so 3 pi over 4. It's this guy. Quadrant 2 over 4. They're both rad 2 over 2, right? But quadrant 2, your cosine's negative. So it'll be a negative rad 2 over 2. And then sine is a rad 2 over 2. And so then that'll give you a 1, or how about, can I just go and get a, that means you're going to add them, and that's a 2 plus rad 2 over 2 divided by rad 2 over 2, right? And then the 2's will cancel, so you've got a 2 plus rad 2 over 2 over rad 2, and then rationalizing that, you got to multiply top and bottom by rad 2, which means I've got 2 rad 2 plus 2 all over 2. And 2 goes into all of those, so it's a rad 2 plus 1. Yep. All right, so that was number 5. Okay. Page 302, number 3. Cosine of 7 pi over 8. And again, using half angles. So what I know is that is 7 pi over 4 divided by 2. Right, where this is your theta. And I know cosine of the half angle is equal to plus or minus the square root of 1 plus cosine of theta over 2, where what I just found by writing that, right, because 7 pi over 4 times 1/2 will give me the 7 pi over 8. So that's 7 pi over 4 is the theta that goes and gets plugged into your formula. There, and there. All right, so that means that this is equal to plus or minus the square root of 1 plus cosine of 7 pi over 4 all over 2. So let's figure out, is it plus or minus? You're looking for cosine of 7 pi over 8 is what they're asking you for. So that's what you base the plus or minus on, 7 pi over 8. Where is that? Well, 7 pi over 8 is what? Well, I know this is pi. and 0 and pi over 2. If I'm comparing it to over 8, then that makes this an 8 pi over 8, and this would be a 4 pi over 8. So 7 pi over 8 is somewhere in quadrant 2, because it's between 4 pi over 8 and 8 pi over 8, and cosine is negative in quadrant 2. So we're going to choose the negative version of this. All right, so that means I've got negative square root of 1 plus, okay, 7 pi over 4. 7 pi over 4 is here. All right, so then that gives you cosine would be a positive rad 2 over 2. I'm almost done. I'm almost done. I'm on the last problem. All right, and then that will give you a negative square root of, that's a 2 plus rad 2 over 2 divided by 2, which gives you a negative 2 plus rad 2 over 4, and rad 4 is 2. So we got a negative of the square root of 2 plus rad 2 all over 2. And there you go. That is the answer to that one. All right, we are out of time. I'm actually over time right now. Right. Let me just look real quick. I'm going to just get that page 316, number 55. Let me just look at it really quick. And it's similar to what we did before. All right, so I'm calling it a night. Good luck. And I will post the recording here in the window.